So during the last session, we were able to progress a little bit further into um, the outline we have on SQL. Permit me to quickly share my screen. Share, yeah, share, share. So as at the last session, we concluded on the different types of data that we have and that we necessarily use in SQL. And after that, we move straight to joining a table or extracting data from not just a single table this time around, as we have extensively done already. We know the beauty of relational database is not just the ability to be able to query out of a single table, but the fact that it is robust enough or flexible enough for you to query out of as many tables as possible. And that is exactly the solution relational database came to solve, and that made flat file database model or type quite obsolete, and it was not going to work. So the edge and the advantage relational database brought to the table is the ability to have as many tables as possible in a particular project, and the table being installed or kept in a single database. Then you can move around all the tables for that particular project and pull out data correspondingly from them. And in pulling out data, like we explained the last class, there must be a relationship already established between those tables, and that is where relational database got its name from. It is a type of database configuration that establishes relationship between tables, and the way the relationship is established is such that there is a connection between the tables, and the connection is done logically through what we call primary key and foreign key. So even though as we advance, for instance, as we'll be taking a couple of examples today, there is still a way we could extract data from more than one table, and we will not necessarily even use um, a primary key or foreign key connecting link. We could just figure out a single attribute or a single field that is common to the tables we want to pull out from. And we can now create the join or the connection on that particular attribute that is common to the tables. And by so doing, the only downside of that is that when a particular table has an entry in a particular row, the other table may not necessarily have an entry in that particular row, and it will not return anything for that particular data point. It will rather render it as null or empty. But the fact is that it will still pull out the data correctly by going through the entire row to check what other entries this other table has in relation to this particular table I'm pulling out from. And if that table does not have anything, it would rather make it empty, but will still pull out something for the other table that has an entry to show. So that is also another way to query out uh, data from two different tables, even if you do not use the primary key or the foreign key, but there must be a particular field or an attribute that is common to both, and that is where the connection will sort of be established. So this is what we try to do in the last section, and we also made use of what we call alias, and that is, for instance, there is a table called students, and we created an alias as a single lowercase s, such that instead of writing students in full, I could just write a single hex. Then the SQL application understands that particular instruction because it's been given already that, okay, wherever you see students, consider it as just S. And that helps to limit a very large name and make the code and even the table a bit legible in a way. So today we are going to into types of join, just like we've seen in the previous session. When you are pulling out data from more than one table, then you employ the use of join. So join is the one trying to say that, okay, while you are considering this table, join your consideration with this other table. And that join statement or join code or join command already tells SQL that, okay, the report you are going to return or the report you are going to pull out should be a combination, should be drawn from these two tables. And the way you need to do it is that the connection is established on so. And that is why that on is also there. That on is also an SQL statement or command that tells SQL where the connection point lies. And it is at that point that the extraction of data or returning of outputs begins from or happens as it is. So that is the beginning of the combination of those tables. But in joining, join is more like the default SQL statement for combining tables to extract data to answer a particular project question. But much more than join, there are different scenarios or different circumstances that can happen, and that can also inform or affect what kind of join output or join return that you receive at the end of the day when the code is run. And that is what is leading us to what we are considering today briefly, which is the different types of joins that we have. So at a glance, a join by default, in fact, all joins, like the join we did exercise on in the last session, is actually an inner join. So any join that is not full outer right or left is the default inner join, but it's not necessarily being called inner join, but that is just the type of join employed in that. So the one we used in the last section is the inner join. So the inner join is more like the direct way of establishing the common areas between the two tables from where you want to pull data out from. So it's more like in simple mathematics when we are trying to deal with set theory, and you have an entity A and you have entity B. Entity A and B, they both have different elements inside of them. So the moment you are merging entity A to B, it means the point of merging is the point where element inside A is similar to element inside B. And when you shade that area, that shows where there is a point of intersection. So inner join is simply telling us the point of intersection between two tables on the same database. And we can see that as we progress. So it returns a set of records or it returns an output that have a data which matches the fields that have been selected in the tables in question. By field, we mean attributes. And by attributes, in a layman language, we mean columns in a table. So data that are matching in in the columns you have selected, or columns that are similar to both tables, those are the area where the intersection occur, and that is where the joining instruction or the joining code happens, and that is where the output will come out from. So it is the shared middle area, similar to that of a Venn diagram, where you have the point of similarity or the point of intersection between two sets. It could be set A and set B, and each of the two sets have different elements inside of them. And the moment they have elements that are, they share common elements. So those common elements constitute a point of intersection. And it is exactly what happens when you are trying to extract data from two tables. If two different tables do not have any field in common, it is pretty difficult to pull out uh, data from them using join. Or else you want to go back to the use of primary key and foreign key. But outside the use of primary key and foreign key, the use of join only comes into play when there is a point where columns are similar, and you can pull out those columns and just establish the intersection or the similarity that is between them. So let's see, that's for inner join, which is the default join. And this is just an example of how it looks. In the middle of these two different sets, sets 1 and sets 2, which represents table 1 and table 2. So that middle where they both overlap is where the point of intersection is. And that is where the join code or the join command works, or um, pulls out result from. Okay, and this is just the example of how the code looks like. It may look a bit strange to you, but it's as simple as what we've been familiar with before. Don't forget, the command select is the most common SQL language, like I've always said. And select is also still telling us, okay, select bike underscore sales. Don't forget, the two tables we want to consider in these examples are tables called bike underscore sales, which is a table dealing with the sales of bike. And the second table is the table called um, bike underscore models, which simply is talking about the different models that the bike we are discussing are made from. So one table is telling us how much sales have been made on those bike. Another table is telling us what are the different models those bikes are actually made of, or are made from. So when you see bike underscore sales, it's just the name of table. And bike underscore models is also the name of another table dealing with the models of the bike. The first one is a table dealing with the sales of the bike. Now, how do we explain this? So the reason this is written this way is that we have bike underscore sales dot trans underscore ID. So trans underscore ID is a column in a table called bike underscore sales. So that should not be confusing. The name of a column in a table called bike underscore sales is trans underscore ID. I will demonstrate that very soon and pull out the table for bike underscore sales in my own server. I will also pull out the table for bike underscore model in the same server. Then I can also run this instruction to see how I want to extract information from the two different tables, going by the point of intersection where similarity occurs. I will show that and demonstrate it clearly. So let's take it one step at a time. So I need to break down this SQL command or statement more clearly. So I have succeeded in saying bike underscore sale is just the name of a table. Don't be confused. And trans underscore ID is the name of an attribute. In this case, attributes, just know that it means column. I can call attribute a field, I can call it an attribute, and I can call it a column. So having said that, uh, I wrote bike underscore sales dot trans ID. That is just referring to a column in a table called bike underscore sales. In the same table called bike underscore sales, I'm pulling out another column called model. In the same table called bike underscore sales, I'm pulling up another column called sales price. So I can correct this. So this is sales price. Yep. Then in another table entirely now, I have changed the table. Don't forget I was running from bike underscore sales table. I pulled out three columns, column trans underscore ID, column model, and column sale underscore price. On the fourth one, I changed to another table entirely, and it is a table called bike underscore models. So I moved to the column called costs. So four columns are being pulled out here, three from one table, one from the other table. Now, having written all those columns, I just specify a set of columns for SQL using that select command. Then I went ahead to say that, okay, all of those columns I've mentioned, pull them out from table bike underscore sales and also from table bike underscore model. That is the essence of this join statement that we see. So pull it out from those two tables, and the connection now should happen in a column called model. So the reason is because I'm pretty sure that both tables have a column called model. So bike underscore sales dot model, that's a column on bike underscore sales table. Bike underscore models dot model is also a column in bike underscore models table. And that is where the joining is happening. So the moment this particular code is run, the application goes right straight into the two tables, pull out the three from the other table and one from this table, check where the joining is specified to be established, get it done at that spot, and pull out the results that is available based on the instruction. And all of these are done in microseconds. That kind of mad speed that the application uses to pull out data. So that is for inner join, or what we call the default join. So the next type of join in SQL is what we call the full outer join. And this type of join, what it does is that it returns all the rows, it pulls out all the rows from the tables you have specified. It could be two, it could be three, it could be more. So all the rows are being pulled out, and this is deliberate. So what it means is that if table 1 has 10 rows and table 2 has 8 rows, and you want to pull out information from the two tables, it will rather generate for you 10 rows instead of 8, even though one of the table has only 8 entries or 8 rows. It will pull out the 10 rows, then the other two rows where the second one does not have anything, it will rather put null or make it empty, but it will still give you the highest number of rows, or the number of rows in the table that has the highest number of rows will determine the total number of rows that will be returned in the output of the command you have issued. So that is why it is called full outer join. And the code is equally similar because in the other one, instead of using inner join, I could use this. I use the exact same code or SQL command that I used earlier in this same particular example. So the only difference is that instead of writing inner join like I did right here, inner join is here, and that is where I instructed the second table to be attached to the first table. So it was called inner join. When you are doing full outer join, then that particular SQL statement changes from being inner join to full join. And at that point, SQL understands what you are trying to do. It will now go ahead and pull out the highest number of rows from the table that has highest number of rows in the 2 or 3 tables specified. Then the other areas that the second one does not have any entries, it will put null or it will make it empty, but at least it will still pull out the highest number of rows that is present in the table that has the highest number of rows. So, and this is how it looks. And this is just the full outer. It shows that everything in both tables are to be pulled out, either the ones that are similar and also the ones that are not similar, meaning both the element at the point of intersection will be pulled out in the return outcome, and also elements that are not are belonging to the point of intersection, they will still be pulled out. So where the gap will be seen in the table eventually that is being pulled out is such that you will have some rows that have no entries in them. They are null. The reason is because the entire rows in both tables are pulled out. So if both tables do not have the same number of rows, then there will be some of the data points in the output table that will be empty because one of the table being joined to the other does not have equal number of rows like the first one to which it was joined by the query that was issued to SQL. So that's what happens in full outer join. Then the next type of join is right join. In this kind of join, it helps to return all records from the right table and only the matched records from the left table. So it goes, I mean, it begins with the table on the right and only pulls out records that are matching from the left table, just as it is here. So recall the first one, it was the middle where that we have the point of intersection. But here, the entire thing in the right table are being pulled out and now being compared to a few things that are now similar to that particular right table, which is just the second table. So both the point of similarity to both tables and the entire thing on the second table are being pulled out. So that's why it is called a right join table. And the point of difference, just like the second one to the first one, is that you will change inner join to full join when you want everything to be returned. When you're not dealing with right join, you change inner join to right join, just like we have it written here. And that's the point of joining on the table. So we can take this little by little just for us to be able to digest it very well. I will probably necessarily pick the first join and demonstrate it on SQL environment where the code will be written and issued. Then we see the tables that can be pulled out. Then we can take our time to understand that one very well. The moment you are able to understand the default join very well, the rest, the remaining three, is just to vary the SQL code before the join. Changing inner join to full join, changing full join to right join, changing right join to left join. The same number of attributes or columns can still be pulled from the two tables being used as examples, and you can now see the difference between the output for the four of them. But I know it may be a bit more for us. I mean, a bit much for us to be able to absorb now. So we take it one step at a time. We can take time to understand the very first default basic one very well. Then we can now build on that thereafter. So the last type of join, is it the last type of join? Yeah, there is still a particular type of join we call what is it called now? Yeah, natural join. We'll get to that hopefully by next section. So, but in this category of um, join types, the fourth one here is left. Just like we had the inner join, we have the full join, we have the right join that is taking the entire table on the right, including the point of intersection with the table on the left. So this left join now, just like the right join, helps to return all records from the left. Don't forget the other one was returning all records from the right, then now match it to the point of intersection with the table on the left. But this one is returning all records from the left and match those records to the right table or to the items in the right table that are matching to the table on the left. And this is just the illustration, just exact opposite of the other one that we had earlier. So the entire entries, the entire data points on the left table, including the point of intersection or similarity with the right table. That is what we use left join command or left join statement in SQL to pull out. So having done this, we can now see a few demonstration of how this stuff work. Okay, where is it now? I have this guy. Yep. So right here, don't forget you can start with this. Okay, even if I use, let's say I use this school underscore demo, it will still pull out what I need for me. Yes, so I am in that database called school underscore demo, and I can also say show databases. It does that for me. Yes, it pulls out these just for me to have an idea of the available databases right here on this server. Okay. Definitely I'll be working with school underscore demo. So also show your show tables for us. Let's see how many tables we now have. Okay, now we have a table called bike underscore models, like I explained earlier. We equally have a table called bike underscore sales. Yep. In addition to the other tables, we already have meals, shapes, students, and teachers. Okay, but for today, we'll necessarily be making use of bike underscore models as a table and bike underscore sales as a table. So we'll be joining those two tables together to pull out some information. So let's see. Select everything from bike underscore sales. That's the name of a table. Write my table correctly. And the command this way. Then I can execute. So here is the table bike underscore sales. So it's showing me the table now. How many attributes, which I called column trans underscore ID, column customer ID, column model, column color, another column for sales underscore price. This the amount realized from every sales that is being made. So 1, 2, 3, 4, 5 columns. Yeah, that is bike underscore sales table. Then I can also check bike underscore models table. I don't need to rewrite it. I already have it here. Just do this, run it. So here I have column for ID, I have column for model, I have column for color underscore option, then I have column for cost. Don't forget, in the previous one, there is bike underscore sales. I have, let's identify what is the common column to both table. ID, model, column, color underscore option, then costs. That's for bike underscore, no, that's for bike underscore model. So let's see for bike underscore sales. Bike underscore sales has column for trans underscore ID, customer underscore ID. It also has a column for model. Meanwhile, we have a column for model in the other one too. It also has color. Then this one also has sales underscore price. Let's see again. That one also has color, but it's not written as color. Okay, that's why we are not going to use it. So let's put model. How does it write its own color? This one color is written as color, just COLOR. How does sales underscore model write its own color? Model is in plural. How does it have its own color? So color is written as color underscore option. So it doesn't carry the exact same name as the other one. So we cannot use it. So the only column that has a column named the same way on both table is this column called models. And that is where the join will be happening. So let's see now, how do we follow up with the join now? We can say select all from bike underscore model. We specify the set of columns we want to pull out from there. And we also specify the two tables from where those columns are to be looked for. And we also go ahead to specify which column should the connection be established, and then pull out the information. So if I do that, I can just run it this way. Then it's going to give me something beyond what I have here. Now for this particular table, which is bike underscore model table. I have ID column, I have model column, I have color underscore option column, then I have cost column. So the instruction I want to give now, I am asking SQL to go into the first table, which is bike underscore sales, and pull out trans ID column, also pull out model column, also pull out sale underscore price column, then leave that table, go to the second table called bike underscore model, then pull out the costs column. And that's exactly what's going to happen now. So for this one of the table, both tables have 5 entries. So let's see what this instruction pulls out for us. Yeah. So here is the output. So the query is saying select bike underscore sales, go and pull out trans underscore ID column. It has gone to pull that out. Go to the same table called bike underscore sales, pull out model column. It has pulled it out. Same table called bike underscore sale, pull out sale underscore price. That has been pulled out. Then go to the next table and pull out cost column. in that table called bike underscore models. And that's exactly what has been returned. But do not forget that in the two tables, each of them has 5 entries. Now, we have gone ahead to request SQL to pull out information from both tables. And the total number of entries being pulled out here is 4. What could have happened? For avoidance of doubt, let's pull out the two tables again to be sure of what we are saying. So, not this one. Yes, this bike underscore models table. How many entries? 1, 2, 3, 4, 5 entries. All right. So let's go to the next one. Bike underscore sales table. Let's change this one to sales. Okay. Come here. How many entries? Same 5 entries. Then when we now pull out data from both, how come we have just 4 entries? Each of them separately has got 5 entries each. But when you are now pulling out data from both of them simultaneously, the output is showing 4. What could have happened? So do not forget that we have specified the point of connection. We have established where the join query should operate. And the join query is going to operate at that point that was originally specified. And the specification is such that if table A has a particular item on that column we are specifying for intersection, but table B does not have any corresponding entry, then there is nothing logical to be pulled out there, because when SQL is returning um, an outcome table for you, is giving you exactly accurate entries in both tables combined without mixing anything with each other. What that implies is that entries in row 2 in table 1 does not go and merge with row 3 in table 2. No, the output is such that entries in row 1 on table 1 matches entries in row 1, same row 1 on table 2. So there is no mix up of one row in one table to a different role entirely in the second table. That will not be a representation of reality, and that will have even messed up the ideal behind data analytics in the first place, because I want to see how entries in A corresponds to B. Okay, A is just dealing with sales. This one is dealing with model. These sales that we made in this row, what model actually fetch us that sales? If it misses up that sale with another model in another row, then that is misleading. But that was not how relational database was configured. It was configured with high sense of accuracy, such that rows per row on either table can be connected. And if they are unable to be connected, it will not even return anything for you at all. And that's exactly what's happening here. There is a particular entry in one of the table that the second table does not have. So instead of reporting a wrong information, it would rather not report that particular role at all, showing that that role are not matching, because this one has a different item in this particular role in this column. Even if this one have a similar column named same way, it does not have that exact name in that particular column on that same row. And as such, it will not return anything from it at all. That's exactly what is happening. Let's see how that happens. Then we can possibly have a better understanding of what I'm trying to drive at. See now, bike underscore model table is this. It has ID, and the ID is such that it's 2010, 2011, 2050, 2087, 2089. Then the model is such that we have Road LX, Road XL, Mountain Y, Racing ZX, Racing ZY. So we have two Racing ZX and Racing ZY, and we have two Road LS and Road XL and Mountain Y. Let's see what sales has on that models table. I mean models column. Sales. So don't forget in model column um bike underscore model, we have two Road LS and XL, two Racing ZY and ZX, ZS and ZY, LS and XY. I mean LS and XL, then Mountain Y. Let's see what bike underscore sales has got in that model column. So in the model column, yes, two Road LS, Road XL, Mountain Y, correct. Now, Racing ZX, there is no Racing ZY. The other one has Racing ZY. But instead of this to have Racing ZY model, rather it has water bottle. So here is this point of water bottle and Racing ZY. So one has Racing ZY, one has water bottle. On this ID number 5, those are the trade-off model in both tables that were given away, and the application could not return it because they don't have a similar name. So if it gives you any costs for any of them, I mean for that particular thing, it will be given a wrong cost because on the costs table it rather has Racing ZY, not water bottle. But this one is having water bottle, so it has already given off this water bottle for that Racing ZY, and that's why the final output on this particular query, which is trying to extract from both table, is such that we do not have Racing ZY and we do not have water bottle. So we have Racing ZX, no Racing ZY. One of the table has Racing ZY. It's not coming out from this output from both of them because the second one does not have Racing ZY. It rather has water bottle. And that's why finally the output coming is 4 instead of 5. Had it been both of them have Racing ZY, then it will have been up to 5 too. Or both of them have water bottle, or Racing ZY, then the final output from this join instruction or statement would have equally given us 5 entries, as both of them has got 5 entries. That is a big testament to the accuracy of SQL. It will not mix up row 2 in table A to row 3 in table B. No, it will only give you corresponding output from one row in a table to the corresponding row in the second table so that there can be accuracy and um, and 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 representation of reality going on in the two tables. So those are very, very important points for us to bear in mind and consider. I think that will be okay for today for us to take time to digest, then prepare some questions or query, if any, that we may necessarily have. If there is no question at this point, then we can call it a session today while we reconvene next week, same time, for another interesting session on SQL. And gradually, what that implies is that we are gradually moving to the end of our discussion on SQL, after which we eventually move to the last topic, which is now on on a visualization application, and that is Tableau, so which is a web-based visualization tool, and it's a very, very good one for that matter. A similar one to it is the Microsoft Power BI, which we have done before, but we necessarily take on Tableau this time around to see how well we can represent our data visually for lay people or non-technical people to see and understand and be able to quickly identify where there are issues or trends going on within a particular set of data being presented. And of course, that could help generate easily as many questions as possible because of the skills of representing data more visually for people to have an idea of what exactly is going on and be able to query one thing or the other from the table or from the presentation being made. So we will do that hopefully immediately after we are done with SQL, which we are actually almost getting done with. Then, if we still have some people who are still interested in taking on another tool, I mean, data analytics tool, then we can now move finally after we are done with this particular comprehensive curriculum. We cannot necessarily do another big master class, which will now be dedicated to the almighty Python, Python for data analytics. So, thank you once again for your time. On that note, we'll be ending today's class. I mean, we'll be ending today's session, and we can take time to digest what we've been doing so far and what we have covered so far too, and get ourselves ready for any questions we may have as we are progressing more rapidly and extensively this time around. Do we have question? In the absence of none, then we appreciate you as always for your time. Then take advantage of all the recordings. If you have any questions, you can reach out to us via all our social media platforms or officially via our email. And those questions or queries will be promptly attended to. Thank you once again for your time. Have a wonderful week ahead. And bye for now.